what animal studies have demonstrated is that not only does MOTS-c increase with exercise, but giving additional exogenous MOTS-c prior to exercise will further enhance exercise performance. Specifically, in one mouse study, after only a single dose of MOTS-c, total running time was increased by 12% and running distance by 15%. Then in another study, when young mice were given MOTS-c for 10 days, their exercise capacity significantly increased with higher doses of MOTS-c regardless of the diet they were fed. For instance, with the higher MOTS-c dose, the young mice were able to run 30 to 50% further in a set time, and they also increased their power output. And then every single mouse that received MOTS-c was able to run at the max sprint speed that they were tested at, while only 16% of the mice receiving placebo were able to do so. And then in the same study, middle-aged mice and older mice were also given MOTS-c, and their aerobic and anaerobic exercise performance also improved. But the older mice also saw an improvement in their grip strength. There are less other studies on strength improvement, and MOTS-c definitely seems to more positively impact those slow twitch muscle fibers, or those that are more involved in endurance performance, compared to the fast twitch fibers, or those that are more involved in maximal strength and power. And this makes sense mechanistically because these slow fibers are much more reliant on mitochondrial function, which is supported by the AMPK activation that MOTS-c provides. And interestingly, in a study looking at a human genetic variant of MOTS-c that has less biologic activity, researchers found that those with this variant, and thus functionally less MOTS-c, had more fast twitch muscle fibers and higher measures of leg strength. And those with this lower MOTS-c activity were slightly more likely to be strength athletes compared to endurance athletes. And then further adding to the story, when mice were injected with a substance made to inhibit MOTS-c, their fast twitch fibers actually increased. So it makes sense that exogenous MOTS-c is more beneficial for markers of muscular endurance when tested in mice, but not so much for maximal strength markers. Thus, MOTS-c has a lot of promise for enhancing any athletic performance that relies on muscular endurance or aerobic or cardiorespiratory fitness. And this is due to that enhanced mitochondrial function.